Hello, everyone, and welcome to the July Recreational Astronomy Night meeting of the RASC Toronto Centre. My name is Paul Markov, and I will be your host this evening, coming to you live from Markham, Ontario. We are online only this evening due to the closure of the Ontario Science Centre. These online meetings are made possible by our awesome AV team comprised of Andrew and Betty Reed, Wardley Grow, and Yuchalucci. And in regards to future meetings, we have one open slot for the August 7th meeting. Later meetings are also available. So if you have something in mind, please get in touch with me. The location is to be decided. It may be online only, it might be somewhere. Our president, Tom Luton, will say a few words about the situation with the Ontario Science Centre during the announcements. Our speakers for this evening are as follows. We have Andy Beaton presenting the sky this month. Then Pavle Krasnopolski will talk to us about Atacama, a journey through an astronomer's playground. And Benjamin Law will talk to us about solar and ISS photography. Tom will close the meeting with announcements as usual, and we should be done around 9:30. If you're watching us online and have a question, please enter it in the YouTube chat box, and Ennio will ask the question on your behalf to the speaker. And if you're watching us online, whether you're a member or not, please say hello and let us know where you're from. So we're all set to start a meeting. Let's get started with Andy and the sky this month.
Okay, am I on here? Hello, my name's Andy Beaton. I'm speaking to you from my basement office in downtown Toronto, which I share with many spiders and centipedes. And I'm here to talk about the sky this month. I have a usual list. People who have seen me speak before will recognize it. The big picture, key dates, the moon, planets, some deep sky stuff, a double star, obviously variable stars because it's me, and whatever's coming up in the world of spaceflight over the next month. So starting with the big picture, this is what the sky is looking like tonight around 10:30 in the Toronto area, looking west. Our spring constellations are disappearing. Leo is setting, followed by Virgo and Botes. What I do note is we've got very little in the way of planets visible. There's a couple of minor planets there, Makemake and Haumea, but very little in the way of the fun planets that we all like to look at. By the time we get around to the next meeting, the morning before, on August 7th, this is just before sunrise, and now we do have some planets. If you're in a planetary mood, getting up early in early August is probably your best option between now and the next meeting. And by then, we're actually starting to see the fall and heaven save us, the winter constellation starting to show up. You see Orion peeking up just before dawn. So what do we have coming up over the next month? Our key dates, we've got not one, but two new moons, July 5th and August 4th. The moon will be at apogee on July 12th and perigee on the 24th. And what this means is it will be closer or farther. And you can actually take pictures and see that the size of the moon differs from those two dates. You can put them side by side, have a little observing project. Earth is at aphelion on July 5th. That is the point where the Earth is the furthest from the sun, which explains why it's so hot in summer. It doesn't, I'm making a joke, obviously, but the elliptical orbit doesn't really have a big effect on our weather. But if you're interested, yeah, you could take a picture of the sun now and take a picture of the sun again in 6 months and compare the sizes as it appears from the Earth. It'll be a much smaller difference than the moon, but it is there. July 21st, we have a new moon, or sorry, a full moon, and the South Delta Aquarian meteor shower following on July 28th. That's actually a bit disappointing. It's coming a bit too close to the full moon for us to really get the dark skies that we like in the morning, but at least we get a meteor shower. The nights are getting longer again. We're past the summer solstice. Astronomical twilight ends around 11:18 tonight and starts again at 2:50 in the morning. Yeah, that's a very short, dark night. Bad news for you astrophotographers. However, by August 6th, it's getting better. 10:18 is when twilight ends, and 3:52 in the morning is when it starts up again. So a significantly longer viewing time. So we've got the moon. Everybody likes to look at the moon, except everybody who likes things in the dark sky. New moon on July 5th, first quarter on the 13th, full moon on the 21st, and last quarter on the 28th, and then a surprise bonus extra new moon. We have the lunar X coming on July 13th. Unfortunately, during daytime for us here in the North America, but if anybody is viewing from the other side of the world, what the lunar X is a pair of craters side by side. When the sun is at illuminating the moon at a certain angle, it makes a neat X thing on appearance of a brightly lit X against the dark shadows of the lower crater. It's a neat thing to see. The lunar straight wall, Rupus recta, is visible for longer than the lunar X. It's more than a few hours, and it's on the evening of July 15th if you want to go looking for that. So we have planets. Mercury is barely visible in the western sky after sunset. You want a nice low horizon, no trees, no buildings, because it doesn't get very high above the horizon. Even closer to the sun for this month is Venus. It has the virtue of being brighter, but it's going to be a tough thing to find for the next few weeks. Mars, on the other hand, is showing up before sunrise. Um, it is very distant. It's only 5 or 6 arc minutes, arc seconds across. It's very small. You're going to be disappointed if you're looking for features. It's going to be very little visible through the telescopes that any of us have, but at least it's coming back, and we can look forward to better views later in the fall. We have Saturn and Jupiter coming in the morning. Jupiter is rising in the morning, and on August 13th, which is actually not the sky this month, it's the sky next month, there will be a very close pass with Mars within the field of view of an average telescope eyepiece. So look forward to a cool view then. We have an extra interesting thing happening on Jupiter this month. 8 double shadow transits. Now, what a shadow transit is a shadow of one of the moons of Jupiter being cast on its cloud surface. Let's see. Yeah, here's a picture I cooked up in Sky Safari. I don't know how well it's showing up over the screen, but you can see a couple of black dots, hopefully, on the surface of Jupiter. That's kind of what it's going to look like through the telescope. You might even be able to see, with a sufficiently good telescope, you can see some of the moons as they're passing in front of Jupiter as well. We call those satellite transits, and so we're not only getting double shadow transits, where we're getting 2 moon shadows at once. Some of them will actually have the moons as well as the shadows showing up in front of Jupiter. Saturn's rising around midnight, and it stays pretty close to the same spot throughout the month. It's not moving very much. It's at that time of the orbit where the Earth is catching up to it. So as far as we're concerned, it looks like it's sitting still. The rings are sort of open, but they're slowly closing. So you get your views of Saturn in as soon as possible because it won't be long until the rings are edge on, and it'll be a disappointing view. The ice giants, Uranus and Neptune. Um, Uranus is rising around 2:30 in the morning, and it's rising earlier and earlier as the month goes on. Midnight by the next meeting. It's visible throughout the night, or after it rises, and is visible to the naked eye in extremely good skies away from the city. Neptune rises earlier, just after Saturn, and it's visible until sunrise as well. Not nearly as obvious to find. You're going to need binoculars and some kind of direction finding software or maps. I know they're dwarf planets and not planets, but Pluto and Ceres are visible. Um, Pluto is in Capricornus this month. It's getting away from the Milky Way in Sagittarius, so it should be much easier to find than it was a couple of years ago. 14.4 magnitude, you're probably looking like you're going to want an 11-inch telescope or better, or you can do some imaging and try and get images of Pluto a few nights apart so you can see it moving against the background stars. Otherwise, it's very hard to confirm you've seen it visually. Ceres is a much easier dwarf planet to find. It's 7th magnitude and currently passing through the teapot in Sagittarius. That's the asterism in the constellation that looks like a teapot. I always like to throw in something in the deep sky. Since we're looking in Sagittarius for Ceres, we'll stick around that same area for M22, the Great Sagittarius Cluster. And this is what it looks like. It's one of the better globular clusters from the point of view of the Earth. This image from our friends at the Canada-France-Hawaii telescope. It's 5th magnitude, so it is the brightest globular cluster that we can see from around here. The southern hemisphere, they get better ones, but this is pretty good. It's an interesting thing because it's between us and the bulge at the center of the galaxy. So what professional astronomers have been doing is using it to act as a gravity lens to look at objects in the bulge in the center of the Milky Way. So it's a neat thing that we aren't going to do, but interesting to know that other people are doing that. And it's also right in the middle of a whole heap of stuff that we see right around the center of the galaxy. There are other globular clusters there. We're right nearby the Trifid and Lagoon Nebula. And it's just a neat place to set up a telescope and just put in your wide-angle eyepiece and just look at the vast numbers of stars there. It's a very nice tourist spot of the sky. And I've gone for a globular cluster because I think globular clusters are the only ones that look way better through a telescope to the naked eye than they do in photographs. You don't get the burnout at the center of the object that you do with a photograph. Now, if you're a more advanced observer and you're looking for something more challenging to do with M22, it is one of 4 globular clusters with a planetary nebula. Now, I don't believe it's visible to the eyeball with any telescope any of us can afford, but I'm hoping photographs could capture it. It also contains 22 variable stars, mostly are Lyris types. Um, people from Toronto would know that there's our own Helen Sawyer Hogg, famous Toronto astronomer, made her career observing R.R. Lyrae stars in globular clusters. So there's something you could emulate. It also apparently contains two black holes. Once again, probably not within the ability of any of us to observe it, but just the fact that they're there is kind of interesting. I mean, I tracked down the star that Cygnus X1 is orbiting, and obviously I didn't see the black hole, but just tracking down the object itself, knowing it's there, was pretty fascinating. So we have our usual boatload of comets and meteors. We have the southern Delta Aquariids peaking July 30th, around 20 meteors an hour, which isn't bad. The phase of the moon is not really in our favor, but we should be able to see something. The Perseids, they're peaking August 12th. Strictly speaking, that's someone else's job to warn you about that because it's next month. But apparently early Perseids can start anytime after July 14th. So if you're out under their dark sky and you see a meteor, trace it back towards the constellation Perseus, and you can decide whether you've seen an actual live Perseid or not. We have a couple of minor meteor showers, the July Pegasids and the Alpha Capricornids. These ones were looking at less than 5 meteors an hour. I wouldn't go out to look for them explicitly, but if you are out under the night sky and you happen to see a meteor, trace it back, see if it is pointing towards Pegasus or Capricornus, and you might have identified a meteor from one of these minor showers. And we've got even smaller showers than that. We're looking at 1 or 2 meteors per hour. Same thing, if you happen to see a meteor, try and trace it back. We've got the C Andromedids, the Zeta Cassiopeids, and the Eta Eridanids. All of them fairly long showers with not much activity. So keep an eye out for meteors. Maybe you've seen one of these rare and obscure showers. We have comets. I wonder if anybody's watching from the southern hemisphere tonight. Sometimes we get people coming in, and you folks are the lucky ones. You get comet 12P Pons Brooks, 7.4 magnitude in Puppis. We can't see it from up here. We rely on you to get some good pictures and post them where we can see them. For those of us up here in the northern hemisphere, 13P Olbers, 7.5 magnitude comet in Lynx, and then some smaller ones. C2023A3, I hope I get this right, Chusenshan Atlas in Leo, C2023V4 Kamarasa Dushanovich in Lynx, and 2021 S3 Pan-STARRS in Draco. I don't think any of these are visually spectacular, but it's always interesting to see comets and track them as they move throughout the sky. Now, we also have a lot of aurora happening. Recently, we had a gigantic auroral display not too long ago. I hope everybody got a chance to see it. It's a busy time on the sun. We may get another auroral display sometime in the near future. Obviously, I haven't heard anything about some tonight, but keep an eye at spaceweather.com for maps and up-to-the-date forecasts. And I'm going to share this with you. This is an image of our big aurora display taken right from downtown Toronto. I mean, it's not the spectacular ones that everyone's sharing online, but I wanted to share it because a lot of us live in the city and aren't necessarily aware that on a good night, you can see the aurora from downtown Toronto or whatever big city you happen to live in. So keep an eye out for forecasts for news. Obviously, if there's going to be a big display like the last one, it's going to be all over the internet, so we should all be able to get sufficient warning. In memory of our good friend Blake, who passed on recently and was the guy who got me hooked on viewing variable stars, um, I've picked a Gamma Delphini. Uh, it's the top left star in the lozenge of the constellation Delphinus, the dolphin. Um, 4.4 magnitude and 5.0 magnitude pair. Um, some sources describe it as yellow, white, and orange. Other sources describe them as orange and lime green. I'm curious to know if people observe it and what colors you perceive. Um, it's always a crapshoot trying to decide what colors these things are when you're relying on human eyes and dark skies. But yeah, I'm curious to see what other people say. They're about 8.8 arc seconds apart, so you're going to need a telescope to split it. And there's an orbital period of just over 3,000 years, so this is one where I wouldn't bother trying to track changes from night to night or even year to year. I don't think we are going to see much of a change in any of our lifespans. I can't go through one of these without a variable star. Z Camelopardalis is the one I've picked this month. It is a cataclysmic variable star of a type called a dwarf nova, related to SS Cygni stars and U Geminorum stars that I've talked about before. It's circumpolar in Canada. We should be able to see it any night where it's clear. And it goes between 9.8 and 14.5 magnitude. So what's happening with this is we have a white dwarf and a giant star, and the white dwarf is slurping material out of the upper atmosphere of the loosely bound giant. The material spirals in through an accretion disk, and what's happening with these ones is rather than a classical nova where material accumulates on the surface of the dwarf, in this case, material is igniting and fusing in the accretion disk, which leads to weird effects. Um, this one's unlike the SS Cygni and U Geminorum stars in that the brightness can stall for a few months halfway between the maximum and the minimum. I'm not sure the process is entirely understood, so this is one where amateur astronomers can make a contribution to science. Get your observations, send them in to the American Association of Variable Star Observers, and especially try and get those observations in as soon as possible, because what's going to happen is professional astronomers studying these stars are going to see from the AAVSO database that things are happening and get their telescopes pointing there for some immediate data collection. So yeah, this is one where you and I can contribute actual science. And because it's a fast moving thing, this is something that the automated sky surveys are not going to catch. So this is up to us. I don't know how many people here are old enough to remember when television shows had summer reruns. We get all the new shows through the winter, and in summer it was the same old stuff. Well, here is a variable star that I posted in my talk a few months ago, and we're still waiting. T Corona Borealis has a recurrent nova that last went into outburst 70 years ago, and we've been expecting it, and it hasn't gone off yet. It should be going. They're expecting it sometime before September. Um, it's another one of those things where we've got a giant dumping material, this time onto the surface of a dwarf, which will build up and go from 10th magnitude to 2nd magnitude, making it one of the brighter stars in the northern hemisphere for a brief time. It hasn't happened yet. At least it hasn't happened when I put this presentation together yesterday. So keep an eye out for it, and you might be the one to spot it. Once again, aavso.org is the place to go for maps and to report the results when you see it. So what's coming up in spaceflight? Obviously, everybody's wondering what the heck is going on with the Boeing Starliner. Are the astronauts really stranded there? Are they just resting while they decide the best method to test the machine before they fly back? Good question. Nobody knows. No one's saying anything. We have the first flight for the Ariane 6 coming up on July 9th. That's the latest of the ESA's rockets. We have a Dragon Polaris Dawn capsule EVA. People are going to be stepping out of one of the Dragon capsules in orbit. They're going to be testing out the fancy new spacesuits. This will be one that'll be fun to watch on TV. Or on the internet, I should say. The ISS is passing over late night and early morning from now until July 30th. Have a look at the ISS now. They're starting to make concrete plans for deorbiting it in a few years. Anyway, heavensabove.com is the place that I go for times and locations. The Event Horizon telescope was the one that I was looking at last time. I'm also going to say check out what's new from the James Webb telescope. And this is one that I dug up a couple of days ago. This is Jupiter in infrared, image from NASA and ESA and all their partners. The brighter colors are higher, the darker colors are lower. It's a view of Jupiter. I've never seen anything like it before, but it's really cool. I would put this as the desktop on my computer just to admire it. So, what if it's cloudy? I always want to wrap up my talk here with something to do when it's inevitably cloudy, because it always is whenever I want to observe something neat. The Zooniverse.org has a ton of citizen science projects, and a large number of them are meant for astronomers. We have the Cataline Sky Survey for minor planets. We have a variation on SETI, Are We Alone in the Universe? We have an active asteroid project where we're examining asteroids for outgassing. Are they related to comets? Maybe yes, maybe no. And we have the Super WASP Variable Star Observing Program, wide-angle search for planets. It's also picking up a lot of variable star information, so that's another project you can get in on. In any case, this is a small selection of the projects available at Zooniverse, and there's an app available for both iOS and Android. So if we don't get clear skies, we can still do some astronomy. And if you've got questions, corrections, I haven't noticed any typos coming through this time, but there always is one. You can contact me at andy.beaton@gmail.com, or on any of the newer social platforms of Mastodon or Blue Sky. And that's what we have. Thanks for your time, and let's have some clear skies.
Thank you very much, Andy. Let's go to questions. Enya, do we have any questions for Andy?
Yes, we do. We have a couple questions, and we have a few interesting comments. So I'm going to combine both of Lewis R's questions together, as they are very related.
Okay.
Question: is there a newer estimation of the number of stars in M22? I haven't checked, but has JWST looked at M22?
Oh, that's an excellent question. The number that I recall reading back when I was in university, and this is a good while ago, is on the order of 500,000 stars. But you're depending on a flawed memory. I wouldn't want to put any money on it. I don't I haven't seen a JWST image of it. It's a good idea. I'm going to go and look for one as soon as we're done here. I'd be fascinated to see how it looks in infrared and see if there are things showing up there that aren't showing up in the standard visual image. So thank you.
So, points that have been brought up in the chat. Eric Briggs discusses whether Dr. Helen Sawyer Hogg spent summer nights at the Newtonian focus of the 74-inch DDO telescope observing M22. Further down in the chat, he mentions that, pardon me, just lost the point. HSH spent the moon dark in June 1939 taking place on Messier 22. It's in her DDO publications.
Excellent. I'm glad to know that. I knew that she had been observing an awful lot of M13, but it would be shocking if she didn't take advantage of M22 as well.
And we have Grace Horvatin, who mentions that in her 8-inch job, she did observe M22 recently.
I have an 8-inch Schmidt-Cassegrain. There it is behind me. And yeah, the stars are uncountable in an 8-inch telescope looking at M22. It's quite spectacular.
And that's all I've got for now.
Okay, thank you very much.
Thank you, Anya. And Andy, I have a question myself for you. You showed a photograph of the aurora you took from downtown.
I did.
How was it visually?
Visually, not quite as good. It was definitely there. I could see streaks of white that were moving. There was no perception of color for the eyeball that the phone was able to pick up. Okay.
So the camera picked up a little bit more detail than what you could see.
When I was young and observing, the idea of photographing nebula or photographing aurora was ridiculous. It was just not possible. And now everybody can do it with the phone we all carry around in our pockets.
Ah, very good. All right. Thanks again, Andy, for a great presentation.
Thank you.
All right. So now we can.
I'm sorry.
Yes?
I'm sorry. The question is literally just popped up on the screen.
Okay.
Is there an explanation for the red areas on the outer areas of the infrared photo of Jupiter?
Those were the things right at the poles, I believe you're talking about. I don't know. The image only came out a couple days ago. It might have to do with aurora at the poles of Jupiter, but beyond that, I'm really not sure. The caption I was told was that the brighter things were the higher in the atmosphere, and therefore the warmer they were. But yeah, I don't know if anything weird is happening at the poles or not. That's a good question.
Okay, thank you, Andy. That's all I've got for now.
Okay, thank you.
Okay, thank you both. We're ready to move on to our second speaker, and that is Pavle Krasnopolski, and he'll talk to us about his journey through the Atacama Desert. Go ahead, Pavel.
Thank you. So yes, my name is Pavle Krasnopolski. I'm talking from my home in North York. This is my first presentation for the Royal Astronomical Society of Canada, so I'm a bit nervous. I only recently became a member in May, and for this first talk, I decided to tell a story of my trip to Chile in 2019, 5 years ago. So this is how it began. So my personal journey into astronomy began in 2017 for the so-called Great American Eclipse, which I watched in Missouri. It was a total solar eclipse. And of course, you could drive there from Toronto, which I did. As you can see from this picture, I was quite ambitious with my setup. Of course, being the first time experiencing a total solar eclipse, I didn't really have the feeling of how quickly it happens, where to look. I knew that, I read about it, but still, things happened much more quickly than I expected. And the equipment didn't work the way I expected. So I didn't really get any pictures, but the first experience was, of course, stunning, as anybody who experienced a total solar eclipse will tell you. So I decided I definitely need to go and watch another one. And I started looking, and apparently the next eclipse was in 2019, in the middle of the summer, well, for us in the Northern Hemisphere, in Chile. And I just thought, wait a second, well, Chile is the prime astronomical location. So this is pretty much just a treat that it happened. The path of totality went through exact places where a lot of observatories, world-class observatories, were located. Of course, it was at close to the sunset, so it was the end of the path of totality, and it was around 5 p.m., I think. And the path of totality went very close to several observatories in La Silla that belongs to European Southern Observatory. And then a multitude of them on Cerro Tololo, Cerro Pachon, and Las Campanas. Well, one thing that I wanted to remember right now looking there, you can see that the middle of the path of totality goes inland, which is mountainous, near the town of Vicuña, which is eventually I decided to watch it there. And it's essentially a single valley that goes from the coast inland. Just, you probably are already guessing where this goes. But for now, I didn't think, at the moment, I didn't think about this. So I started planning and researching, and just a little bit of theory now of why Chile is such an excellent spot for astronomy. First of all, it sits right on the coast of the Pacific, where there is this so-called Humboldt current, which is very cold. It flows from Antarctica. It produces very thin layer of turbulence and convection and moisture, which which stays very low over the ocean. And because most of the desert is elevated above the ocean, it doesn't experience any of that disturbance. On the other side, in the east, it's limited by the Andes Mountains, which are quite tall, which give the rain shadow from all of the rainforest in the east. And it's also quite empty. There's low light pollution. But yes, it does experience some strong earthquakes. It sits near the fault line. So all of the observatories have to be built with that in mind. Just to illustrate that, the Humboldt current, and you can see the moisture produced by the ocean from there. That picture was actually from the satellite today. You can see all the moisture just goes away from the continent, and the skies are perfectly clear over the coastal Chile. And of course, you also have the high mountains. In the picture on the right, you can see the so-called high plains or altiplano, which sit at about 5,000 meters, which means there's less atmosphere above them, and which means there's less moisture. So you can, for example, set up a radio telescope with moisture not interfering. One of my destination was there. Just another illustration of that. This was also taken today. The boundary layer essentially sits within the first kilometer of the atmosphere. And you can see that above about 2 kilometers, there is quite stable atmosphere, stable air. And of course, the astronomers have taken advantage of that. But I guess enough of the theory. So I started planning. One great inspiration that I found was on the website called Cloudy Nights. It's actually an excellent resource on everything concerning astronomy, amateur observing. And the article was called 6 Months Observing Upside Down. It's from 2017. Also, you need to take into account that, of course, all of the best accommodations, especially concerning astronomy, would be fully booked many months in advance. Well, there's also the eclipse, so just crowds of regular people were also moving there. And, well, unfortunately, I somewhat procrastinated, and 2 months prior, it was all fully booked. So I didn't get to visit, for example, Space Ops and similar places that offer you actually the accommodation with telescope time, which you can rent. But I could still book a tour of the VLT. That's the Very Large Telescope, belonging again to ESO, European Southern Observatory. And you'll see my visit there later. So this was the plan. It would involve flying from Santiago of Chile to Antofagasta, a big industrial city, and then renting cars in both of the cities to explore around. So usually people will go into the more inland, into the higher mountains through San Pedro de Atacama. It's quite a touristy town, a bit crowded, but then you also get to visit this radio telescope called ALMA, Atacama Large Millimeter Array, and of course most other destinations are along the shore. So I landed in Santiago and decided to, well, and then I of course took the airplane to Antofagasta. And this is where the first part of my journey began. I decided to title it No Water, No Air. And it concerns ALMA, the radio telescope that takes advantage of high altitude and extreme dryness of Atacama Desert. And so this is my flight from Santiago to Antofagasta. This is how most of Atacama looks like. There's pretty much no vegetation. You can see Andes in the distance with the snowy summits. And there's something else that you might see here if you know where to look. So, so this group of structures is the Very Large Telescope. In front, you see the actual telescope on the summit of Cerro Paranal. And then there is the village with residences and industrial buildings. There is also a small telescope on the side called Vista. And in the distance, there is a place under construction. It still is under construction 5 years later, although mostly finished, which is the mountain called Cerro Armazones, where they are making the extremely large telescope. You can maybe make out the top is leveled already, prepared for the construction. So anyway, this was my first impression, first thing I saw of the Atacama Desert, and it already had telescopes in it. The ALMA itself is a collection of 66 microwave antennas, 12 meters in diameter. Those are large dishes. It's situated at an altitude of 5,000 meters on a plateau called Chaknantar. The air pressure is only half the normal, so you might experience altitude sickness or weakness. So you need to be prepared for that visit and maybe spend some days at intermediate altitude. Most people choose San Pedro de Atacama. But you can use nearby mountains to actually look at the telescope that are open. Basically, it's a desert. You can go pretty much anywhere. And there's this Cerro Toco, the mountain close by. Just to give you the impression of the geography there. So San Pedro de Atacama is the touristy town, kind of. And you can basically just drive from there to the altitude of 5,000 meters. This big road goes all the way to the Altiplano and then over the border into Argentina. The Chaknantar Plateau is on the right. That's the this kind of scientific preserve or something like that. And Cerro Toco is nearby, so you can easily see the plateau from there. I didn't get to go to the mountain, to the summit of the mountain itself, because, well, it's quite physically challenging. And that's what I saw from the slopes of Cerro Toco. So first of all, you're already very high up. You can see the rocks are yellow, so there is sulfur from the volcanoes, there is smell. But in the distance was the Chahnander Plateau with the telescopes scattered around it. My understanding is that those telescopes can be moved from time to time to create different arrangements to look at, well, maybe at different angles, maybe look at objects with different resolution. By the way, the recent images of black holes were created by an arrangement of observatories, this ALMA included. I tried using my binoculars to get a better view. So those are the dishes. Yes, they're 12 meters in diameter. Now the atmosphere is very thin. You can physically feel it. It's you always feel exhausted at 5,000 meters. But that's very helpful for microwave astronomy because obviously the water vapor would prevent radio waves, especially high frequency radio waves, of prevented from penetrating the atmosphere. And I think the frequency range goes up to 1 terahertz, so 1000 gigahertz. Atmospheric absorption becomes very important there. But in any case, it's not just a place where you can, well, look at the telescopes. It's just a stunning view all around. Anyway, so after that, that was a brief visit there. I returned, well, into the denser air. I returned to Antofagasta to actually go to the tour of the VLT, the Very Large Telescope that I booked previously. And here's the location. So you have the Cerro Paranal, which is the location of the VLT. And nearby you have Cerro Armazones, which is the future location of the Extremely Large Telescope, the ELT. And they're surprisingly close to the ocean. So you can see the scale of 5 kilometers there. So Cerro Paranal may be about 15 kilometers from the shore. But despite this proximity, there is absolutely no effects of the ocean where the telescope is located, thanks to that cold Humboldt current, which keeps all of the marine layer pretty much at the shore. Well, I had to get up early and drive to the VLT. It's only about 1 hour drive from Antofagasta, a big industrial city. I got a company of some bikers there. Excellent view, just absolutely stunning landscapes. And something awesome that I noticed is that all of the observatories will have road signs, not just with the title, just boring words there, but this cute little picture with stars in it. So Chile really values its position in the world as the prime astronomical site, and it really welcomes observatories there and really tries to make them happy. Anyway, so the drive continued. The Cerro Amazonas was the turn towards the ELT. And then the next turn, of course, was to Cerro Paranal, which is the site of the VLT. Eventually, you go on the this winding road on the into the mountains, and gradually you start seeing the signs that urge you to dim the headlights. So the cars that go there at night will not interfere with observations. Actually, despite dimming the headlights, you still are safe because there are really dim yellow lights along the edges of the road. Actually, you might actually see one right in front of the hood of my car here. Those are lights that lit up at night. And basically, beyond a certain point, you must turn off all the lights in your car. And eventually, you get up and you see the VLT on the top of the mountain. So VLT itself, it consists of 4 big telescopes, just over 8 meters in diameter, with a bunch of smaller auxiliary telescopes. And on the right here in this frame, you can see there is a large parking lot, essentially. That's where people often go stargazing. My understanding is this is still outside of the actual property of the VLT, but obviously I think it goes without saying that if anybody goes observing there, it's essential to not interfere with the telescopes. So all of your lights must be off, no flashlights, nothing like that. Actually, later that day, I went observing at night in this exact spot. There were a couple of people who were using flashlights, and that was very inconsiderate. But for now, I was going to the tour. And this is how it happens. So first you arrive at the gate, and you can see the ocean in the distance. So it's really, really close. Of course, the atmosphere was perfectly clear all the time. You get to the gate. You do a bit of a tour in the building right at the gate there. You are given some hard hats because you will be going inside the telescopes, which is essentially an industrial object. It's an industrial place. And they ask you to keep the curtains in the bus closed because of the ultraviolet light. But eventually you are bussed to the top, to the summit, and there's a lengthy tour. There's tour guides available in most languages, at least in most European languages, probably in Chinese and Indian, I'm not sure. Lots of tourists from Europe. And of course, when you go inside, first you go inside the scientific kind of engineering building. You immediately start seeing that this is truly a playground for scientists, for engineers. You can see people don't just work there, they enjoy their time. For example, there's some inside humor. So of course, the resolution of these telescopes is the reason why they were built. The large mirrors provide extremely high resolution, and the place itself has well-known, very excellent seeing. So atmospheric seeing is essentially the turbulence that causes the stars to twinkle. And in this place, there's pretty much no turbulence. And then we get to go into the main telescope domes. You can see the mirror itself down there. You can see the secondary mirror up on the structure. It's an absolutely monstrous, monumental structure. And to think that they managed to make it accurate to within less than a wavelength of light is, of course, huge engineering achievement. But despite this, the structures that are accurate to the smaller than the wavelength of light still need to be maintained. So you do see just regular industrial scenes around. Well, you can still probably think of it as a playground for technicians. Of course, you also see the steam. You can see it pouring from under the sensors of the telescope. The sensors are cooled by liquid nitrogen. Then there is the residence. That's where people live and spend, well, not the nights, but their sleep. And actually, when you go visit, you must stay very quiet because a lot of astronomers sleep during the day, and at night they observe. It's absolutely beautiful inside. There's a pool. And an interesting thing about it, that pool there is not for swimming. It's for maintaining the humidity that's tolerable to humans. Outside, the humidity can go all the way to single digit of percent, and usually does, which is why this is such an excellent location for astronomy, but not as good for, well, for pretty much anything else to live. It's very hard on your throat, your nose. After several hours there, you will start experiencing the dryness. So after the VLT, I also went to look at the future site of the ELT, the Extremely Large Telescope. You might see the mountain with a flattened top. That was its state in 2019. By this time, now 5 years later, they started to build the dome itself already. But back then it was just a foundation, and they only leveled the mountain. Of course, you cannot go directly into the construction site, so that's the closest I could get. Well, just driving from there was an absolutely stunning view again. You can see the VLT again in the distance. You can actually see the two telescopes from each other. Those are rather tall mountains. The desert is absolutely lifeless, but also absolutely vast and mind-blowing. So anyway, that night I decided that I should definitely return to that parking lot and do well, at least see how it looks like, how the sky looks like in the prime astronomical location. Now, unfortunately, I didn't have some good equipment back then, so I'll have to use a picture from ESO. But I can testify that this is pretty much how it looks like in person. Now, this is, of course, is a panoramic picture, so it's a fisheye lens. But several things to note. First thing that immediately just blows your mind is the number of stars that you see. Right? It's not a sprinkle of stars; it's essentially a carpet. Any area of the sky that you look at will have a star in it. And if you look very, very hard between the stars, there are more stars between them. The Milky Way, this being the southern hemisphere, is right above you. The center of the Milky Way is actually in the southern latitudes. You do see the Magellanic Clouds, and surprisingly, you see all of the colors in the Milky Way. Usually you don't, because it requires dark adaptation, and your eyes don't see color very well at night. But things like the Carina Nebula, extremely bright red spot in the sky. And something that I noticed is that, yes, I brought my telescope and binoculars, but I ended up spending most of the time just staring at the sky with my bare eyes. It's because this is how you get the most unusual experience. There you can actually feel the immersion in the space. It's not just a picture that's in the sky. You feel that you're on this planet that's physically in the middle of this enormous object, the Milky Way, you feel the full presence. And yes, the stars don't twinkle at all. There's the sky was perfectly still. There's absolutely no no seeing, no scintillation. Scintillation is also an effect of turbulence where the stars seem brighter and dimmer, well, essentially the twinkling. And by the way, the laser guide stars from the VLT are not that intrusive, which I thought they would be because those are just very powerful lasers shooting in the sky. But the atmosphere is so clear that there isn't much scattering. That was definitely the most unusual, the most fascinating experience I've ever had in doing amateur astronomy up to this day. So, all right, my next destination was in the area of La Serena, and well, you would assume that being a desert, that would be almost empty, right? So I was going there to watch the eclipse finally. Well, maybe not so much empty. It seemed that most of Chile, maybe a good part of Argentina, a good part of Europe, and some crazies from North America like me descended upon Chile. Pretty much everything that could be rented was. You can see the taxis had the announcements essentially painted on them. All pieces of land were for rent, for parking, or for camping. People were renting out vans to sleep in. It was absolutely crazy. And so remember that this valley, which is called Elqui Valley, was pretty much directly on the path of totality for the eclipse, and it was the only accessible area in the vicinity of the eclipse. Eventually I got there and started setting up and looking around. And of course, those other observatories here, I believe this is Cerro Tololo Observatory, which essentially on the mountain towering over the Elqui Valley, easily visible. And yes, eventually I started setting up for my eclipse observing. By the way, the observatory is still on the mountain there in the distance, in the background. Found a clear spot, set up the telescope. That was the second experience of eclipse I had. This time, there was actually a farm nearby, so I could hear the animals first going quiet, and then as the eclipse approached, just going crazy because, well, obviously animals don't understand what's happening. And total solar eclipse could be a scary or extremely disturbing sight, even for people who know what to expect. Eventually, yes. Obviously, the totality came. I don't think I had good pictures from there, but probably this frame is the best that I could possibly get. And as you remember, this was in the evening, so it was time to head back. And apparently this is what everybody else in the valley also thought. And so my experience for the next 6 hours was essentially this. It took me until midnight from the sunset that happened during the eclipse, more than 6 hours to get to La Serena, only 50 kilometers. This was definitely the worst traffic jam I ever had. as well. But eventually I got there. I got back to Santiago, flew back to North America. And this was pretty much the end of my experience. Definitely the most unbelievable experience, and especially in astronomy, in my life. I definitely want to go again to Chile sometime, and it should be longer than 10 days. I'll want to go there for a couple of months when I do. So that concludes my talk. Do you have any questions?
Pavel, thank you so much for presenting to us, and welcome to the RASC Toronto Centre as a new member. You did a great job conveying your experience and how amazing it was being there. The video clips were also really well done and really helped us experience it as well. So thank you very much and well done. Ennio, do we have any questions for Pavel?
We have a question, and let me start by saying, agreed, very well done. That was quite interesting. We have a question from Lewis R., who asks, did you do this trip alone?
Yes, I did it alone, actually. I don't know. I just find it easier to plan everything out because I don't have to mind other people traveling with me, and yes, I did it alone. I don't think I had any difficulties arising from that. Chile is a very safe country. Well, obviously there's some petty theft and stuff like that, but there's very little of violent crime or something like that, so you don't need to worry about much. Also, the wildlife isn't really dangerous. Well, there isn't much life in Atacama Desert in the first place, but even with that, the well, you don't have millions of spiders or snakes or anything like that.
Cool. We have a point brought up by Betty Reed. The Atacama Desert is the driest desert in the world. Chile is also geographically interesting. It's 4,200 kilometers long and approximately 180 kilometers wide at its greatest width. And one clarification that Andrew Beaton brought up from his talk previously. Lewis R., I misremembered. M22 has 83,000 stars with a combined mass of around 500,000 stars. I had the number right, but the wrong fact. And that's all we have.
Sorry, is there a question?
Nope, there are no other questions.
All right, sir.
All done with questions. All right, thank you, Ennio, and thank you very much, Pavel.
Thank you.
Okay, we're ready to move on, and I should do this, get a little better lighting here. Let's move on to our next speaker, and that's Benjamin Law, who spoke to us a few months ago. So he's coming back with an update to his imaging, solar and ISS photography. Go ahead, Benjamin.
Hi, everybody. First, I would like to thank RASC Toronto Centre for inviting me to share with you this evening about taking picture of our own star and ISS. So I'm Benjamin, sharing with you here from Stouffville, Ontario, in a room with no AC. Yes, my AC broke since the end of May and it's not fixed yet. But anyways, astrophotography is only my hobby, and I'm not a professional photographer, but I hope through this evening I can share with you some of the photos. And also, just like every other hobby, we all may be at different stages in it. So feel free to connect with me through my social media account, which will be shown at the end of the presentation. Astrophotography is a very interesting hobby. Not a popular one, I would say, but a lot of people misunderstood what that actually is. When people are not involved in this hobby, they may think what astrophotography is all about, as you can see from this picture. Unlike daytime photography, you mostly take a picture and see what you get almost immediately. Astrophotography takes time. lots of time, especially in preparing and getting ready for the processing after each shot. I can categorize astrophotography into 4 main areas: wide field, deep sky, planetary, and solar. And each will take a different level of challenges if you want to take good photos. So generally speaking, for solar photography, depends on what you want to do. A simple white light filter may be good enough. If you want to do a little bit more fancy, you can get one of these solar telescopes. So here in this evening, I just focus on taking picture of the sun and the ISS. Just like taking picture of the night sky in other categories, the learning curve is always steep. It is easy to do it, but the fine-tuning of the data and the processing skills will take some practice. In any domain in astrophotography, I learned that there is always a solution for every problem. One of the biggest problems in astrophotography, in my experience, is light pollution. I live in Bordeaux 7 or 8 in northern part of GTA area. Here, my neighbor, I think they were trying to make it Bordeaux 99 randomly. My neighbor installed the pot lights around the entire house, of course, including the side facing my backyard. So solar imaging has the advantage that, of course, it is independent to light pollution, but it's heavily depending on the stability of the atmosphere, the so-called the seeing of the sky. The main gears I use for solar imaging, I have a used Lund solar telescope a few years ago. And as I'm doing more and more community outreach with different community groups, I purchased the Solar Quest mount, which is a game changer. It has an internal GPS and that can track your time and location, and it automatically slew to the sun and center it in your eyepiece or camera within a minute after you turn it on. So it is a very, very good investment to me and for solar observation and imaging. The disadvantage for such mount is that Solar Quest is just like an altizimuth mount. It is subject for something called field rotation. That means the sun disk will slowly rotate in the field of the view. And field rotation, in my opinion, is not a big problem because the video length of a typical picture is about a minute. But it could be a problem for creating a time lapse that lasts for hours. So this can be corrected using different softwares in the processing stage, but it is really painful to do that by software. Sometimes if I want to be more fancy, have more time, I will hook my solar scope with an equatorial mount. The advantage, of course, is having no field rotation, but it will take more time to set up, and tracking is not as good as the Solar Quest mount because polar alignment during the day is a little bit tricky and it's not quite accurate. Is there any solution for solar tracking? Yes. The Hinode Solar Guider, I just checked last night, it is nowhere in stock. It is pricey, but it is hard to get. I discovered that there's a way to actually track the sun using the fire capture software, and I'm about to test it out. And if I have good results, I can come back and share that with you. So there's another possible combination using my existing setup. I have a Celestron 8-inch telescope with a smart light filter, with a white light filter in combination with an equatorial mount. And the white light filter is not able to give you any details of the solar prominences, but it is great for partial solar eclipse, satellite or planetary solar transitions like ISS, Venus, or Mercury solar transits. For example, this is what I took in 2012, the Venus solar transit. I used as white light filter for that. And this one, I used a white light filter for the Mercury transit in 2016. Yeah, but you don't see much features from any white light filter. With any setup of solar imaging, we would like to use a camera with a higher frame rate. With a higher frame rate, you can capture more frames in a shorter amount of time. The more frames you capture, the better result we can get after stacking. Think about it. If the target of what you're trying to shoot is static, which means it doesn't change at all, then the frame rate doesn't matter. Like galaxy, nebula, they don't change. But for planetary or solar imaging, they do change rapidly, especially when you zoom into the planets or the solar prominences. You'll find that they are moving rapidly. So camera with high frame rate will usually get a better result. These are the two main cameras that are used for solar and ISS imaging. They are both mono cameras. Cameras from other manufacturers, I know they're also good. The focal length for my Lund solar telescope is about 500 millimeter. So to get a full solar disk, I would just need a camera with a bigger frame size and also have a higher frame rate. So the Apollo M Max will do a good job. If I need to zoom in a little bit more, I would use the Celestron 2X Barlow or the Teleview 3X Barlow to zoom in the special features. So how do we know what to expect in the field of view for your setup? We can plan ahead and see the expected frame using astronomy.tools website. It is a very handy website for us to predict what to expect from the camera view. And I've tried various capturing software. Fire Capture is always my favorite. It works well with ASI or Player One camera because I have the fire capture for high-speed imaging for planets and solar, but other software is also as good as this one, as long as we feel comfortable with it. Just like taking picture for the deep sky objects, we may want to take flat field or flat frames for solar imaging. Yet I have to admit that sometimes I'm just being lazy for not taking flat frames because I know there are some ways to correct the gradients in Photoshop, but the flat frames can definitely help making your final image more better without the gradients. And the gradients is very common in any solar telescope. I've tried two different ways to take flat frames for solar imaging. The first way is to put a thin Ziploc bag or just a clear plastic bag around the front lens. And the second method is called the defocusing blur. You simply move the focuser back for around ½ an inch, and then these two methods I found they're pretty good as far as I know. Stacking is the way to make the final image more clear, more defined with better contrast, and with less digital noise. Many of you probably know about the software AutoStacker. It is great for stacking planetary and solar imaging. And there's a great tutorial, a bookmark right here. It is included in this slide. Here is a basic workflow in AutoStacker from my experience. You analyze, you draw the alignment points, you determine the percentage of frames to stack, and then you stack it and save it. It's pretty straightforward. Now, after stacking, we will need to sharpen the image. I've tried two various methods. Both are good. However, IMPPG, which is a software, I don't know why, it tends to give me pixelized results. But the Blur Exterminator, which is a paid software, is a plugin for PixInsight. I found it gives you a more promising result and more natural looking result. Now, I used mono camera for my solar imaging that I will show you in a moment, and they don't give any color. So if you want to give color images, you need to do some processing about it. Even though if you use a color camera, sometimes the colors are not what you want to have. So we need to do some manual colorization. With the setting of these individual channels, okay, so for red is 2.0, green is 0.8, blue is 0.2. You can do that in Photoshop or a free software called GIMP. You can actually create the golden red color for the sun disk or prominences. Here is a general workflow for my solar imaging. I just want to highlight that focusing is very important. By spending more time in focusing, you will have a better chance to get better image. Another thing is a saving parameter. I had an experience when I was trying to take time lapse of the sun over a few hours, and the recording stopped recording after 15 minutes because I didn't know that the saving parameter has suddenly moved back to the hard disk on my laptop instead on the portable hard drive that I'm supposed to use. So these videos take tremendous amounts of disk space. So if you want to get into solar imaging by taking image and videos of it, make sure you have enough disk space. I personally recommend getting one of these solid state drive, external drive for solar imaging or planetary imaging. So nowadays, the 1 terabyte external solid state drive is about $100 now. That's a pretty good deal. And I'm not promoting for Amazon, but the Amazon Prime Day is coming up. And I just saw that there's a 2 terabyte scan disk external hard drive for $165. I would say that's a pretty good deal. So from mono image to color image, you can actually do that processing using a software, GIMP, or Photoshop, equally good. This is a solar image on June 21st, 2023. You can see a lot of great solar prominences and different features around the sun disk. And the solar prominences, I hope it's not surprising to you, they are huge. And this one is especially, you can see that the solar prominences through a hydrogen alpha solar telescope. And for a white light telescope, you won't be able to see anything like that. Sometimes if you want to take the solar prominences clearly, you need higher exposure. That means your exposure, your shutter speed should be higher. So instead of having a way overexposed solar disk, you may want to cover the disk with a black circle or black part of the circle such that the viewing experience is more pleasant. So you see here, I can actually put the scales, right, in relation to the size of the sun, or put the Earth as a relative scale to show the size of the solar prominences. This can be done actually pretty easily. So what you need to do is to Google LUOSOL 3D. It is a Spanish program, but just Google it, download it, and you need to install Java for that. But once you play around with a few minutes, even though, like me, I don't like Spanish, you probably know how to work on this software very easily. So you just need to draw the size of the sun and then click a few buttons. All these scaling will be shown automatically on your picture. This one is a time lapse. It's composed of many video frames I took continuously for 80 minutes. You can see the solar prominences is actually moving pretty quickly. They're moving pretty quickly. So I forgot how many gigabytes of data I have used for this time lapse, but I save it on my external hard drive. And this solar prominences is huge. It is taken in March this year, 2024. You see the width of this solar prominences is almost the same distance as the Earth-Moon distance. This is humongous, humongous. A solar disk that I took in March this year, you can see there are lots of different features. The middle part right here is a solar flare, class X 1.1 solar flare. If you look at my picture through my social media account, you will find the details of exposure times and other settings and everything that I put on my social media account. Another, sorry for the spelling mistake, this is June 1st, 2024. And remember the huge solar geometric storm on May 10th that caused all the aurora borealis? It was caused by the sunspot AR13664. And when it spun behind the sun and come back again, it has changed the name to AR13697. This is a huge, and there's also a huge solar prominences in the middle of the sun. So this was the solar flare caused the May 10th geometrical storm. There's a different way to process the sun disk. Here's my first attempt, processing the sun in an inverted or negative manner. In the processing style, the sunspot appears in the sunspot and the solar prominences. They appear in white, and the solar flare appears in dark. Personally, I don't quite like this processing style, but I was just trying to give it a try. Oh, this is a beautiful solar loop prominences very recent on June 24th. You can see the size of the Earth compared to the size of the solar prominences. This is huge. This time lapse is working what scientists call the coronal ray. It's hot plasma condenses in the strong magnetic field and falls back to the photosphere. I just got this photo this morning, July 3rd. There's a huge solar prominences observed today. So here's a setup that I used this morning, and I used the 60 seconds video, stack 50% of all the frames at 135 frames per second rate. Now, for solar imaging, of course, there are other special occasions, especially when the sun is blocked by the moon. This is the partial eclipse that I really like on 2021, June 10th. It has been a few years, and I did not use any filter for this picture. The sun, partially covered by the moon, just climbed up the horizon at around 5:30 that morning. And this is a partial eclipse in 2023. It's taken through my solar telescope during the one and only 30-second break during the eclipse. It was cloudy throughout the whole day, but I found a 30 seconds cloud break. Now, 2024 eclipse, I'm sure many of you have also seen that. Let me just show you the excitement of this total solar eclipse. The quality is not great because due to my poor cell phone camera, but you can feel the excitement right here. 40 seconds. Observe umbra approach. 30 seconds. Hands on camera filters. Look at the sunset. 20. Remove camera filters. 15. Is it Venus? Venus was visible in the sky. Venus. 5, 4, 3, 2, 1. Glasses off. Glasses off. Observe for planets and stars. Wow. See the 360 sunset? I tell you, this is the most amazing celestial events we've ever witnessed. Last time in 2017, Pavel, I was also in Missouri. So we were very close to each other, but we didn't know each other back then. So I went to Missouri for the 2017 eclipse. I did not bring my kids because they were pretty young. And so this time, all my three kids were a little bit older. So me and another family originally planned going to Buffalo for the eclipse. We booked a hotel 18 months ahead of time. But on the Saturday before the eclipse, 2 days before the eclipse, we decided to go to Montreal instead of Buffalo. And it was a good decision. Even though the eclipse was behind the thin clouds, it was a very beautiful eclipse. It was even more beautiful than the one I saw in 2017, to be honest. This place, 30 minutes south of Montreal, is extremely beautiful. It is facing the lake, and you can observe the whole eclipse, with very, very good scenic view. And here are all the gears that I brought this time. So I observed the eclipse last time in 2017, but last time I flew there. So you probably understand that what we allowed it to bring on the plane is fairly limited. But this time it was a road trip. So I decided to bring everything. So these are all the gears that I brought for the eclipse this time. And here's a time lapse that I took using a webcam, a $30 webcam from Amazon. I have to say that I didn't need to worry about destroying the sensor because I just put a webcam facing the sun for a few hours. Because of the short focal length, the wide angle of the sun, it doesn't really destroy the sensor of the webcam at all. So even though it does, I was thinking, it's okay. It's only a $30 webcam, but it does good. It does give me pretty good results. Here is a snapshot of one of the frames from the webcam that I used. You can see the total eclipse pretty well. You can see the boundary of the shadow thanks to the thin cloud. You can see the boundary of the shadow pretty clearly. And I learned from my first eclipse experience, I'm much more experienced and prepared this time. So on my camera, I used bracketed exposure. So this video shows you the differences between 3 different exposures that are continuously taking during the 3.5 minutes eclipse. These are all without any filter, no filter. And this photo is actually taken by my daughter. She used her cell phone to take the eclipse photo, and it was beautiful. Now, I want to share with all of you some of my favorite eclipse photo from this year. Here is an HDR version showing the prominences as well as the corona. This time the sky was covered by thin clouds, but it is visually much more better than the last one. As we can see, a lot of the pink color prominences around it. They were very clearly seen by eyes. By the way, there's no need to use any filter during totality. And here's a collage for different phases during the solar eclipse. Here's a diamond ring for the eclipse in 2024. And I composed this image from SolarScope and the one during totality without any filter. And because my camera was working nonstop for the 3.5 minutes totality, this time I was able to capture the Billy beats. These are actually created by the mountains on the moon when they just being covered by the sun. Part of the sunlight can pass through and show you this Billy beams phenomena. And this one is showing you the beautiful solar prominences. There's no filter used in this picture. This one is a little bit interesting. I always say that for astrophotography is a combination of art and science. So I took the same moon in June 2023, and 10 months later, the same satellite, the same moon, covered the sun by almost the same amount. I love this composition. Here's another composition. It is my favorite eclipse photo. It is a composite photo showing all the visible solar prominences during the eclipse. So it is composed of 3 different photos between second contact and third contact. So you can see all the solar prominences around it. Now, this one shows you the ISS lunar transit. Do you see the ISS at the bottom video here? It may be too small, but if you pay attention to the bottom video, you see there's a dark spot just moving across the lunar disk. Now, ISS transit, it could be very, very small. And this is my most recent solar transit for ISS. On June 14th, I drove more than an hour to get into the center of the narrow shadow of ISS. See the ISS transit on the sun disk. It was exciting. So I was lucky. The sun was totally covered by clouds 5 seconds, literally 5 seconds after the transit was over. So, and this is the composite picture of all the ISS moving through the frame. And sorry, the sun looked very flat in this picture. So to predict exact moments for the lunar and solar eclipse, you probably know that there are many websites that can give you the prediction. And my personal favorite is the transitfinder.com. So for example, last week when I checked this website, I found that there's a lunar transit happening right in my backyard on July 11th. I was quite excited because it was just right inside my backyard. I didn't need to go anywhere. I can also use my bigger scope, which is not portable, for the lunar transit. But now when I checked that this morning, that path has moved 60 kilometers north from where I live. So it's okay, but now there's now a new transit close to where I live on July 13th instead. So the path of ISS does change and get updated from time to time. So I would say the prediction within 24 hours will be pretty accurate. What about zooming into ISS and taking some pictures of it? First, the challenge is that ISS is a moving target. With an altitude of 400 kilometers, with an orbital period around 90 minutes, does it mean that it is not possible to take a picture of the ISS close up when it moves in the sky? Well, actually, it is possible. And because of the Earth is not flat, it is a sphere, the distance between us as an observation point and ISS depends on the altitude of ISS in the sky. The more closer to above our head, the closer it will be. The closer it is, the bigger the image you can get. The closer it is, the faster it will move in the sky, however. So if we live anywhere above 51.6 geographic latitude, we know that ISS will not be directly over your head. So Toronto is 43 north, and from time to time, you'll find ISS will be kind of passing above your head. So how do we know? How do we know when and where we can see ISS fly over? There are 2 main websites. They do pretty good, reliable information. The first one is called heavens.above.com, and the second one is astrophotic.com. These 2 websites, they both have mobile apps you can download on your phone. So as I said, ISS is a moving target. It is like, think about it, it's like taking a picture of a tree from a moving vehicle. On top of that, there's something called the seeing conditions, which is the atmospheric stability. It plays a big role in your image quality. And also ISS is extremely, extremely small. The largest angular size is about 63 arc seconds. When it is directly above your head, which is equivalent to 1/30th of the full moon, or 1/60th of your pinky when you stretch your arm out. It is extremely small. And the field of view of my setup is about 1/3 of the size of the full moon. Because it is moving so fast, we need a camera with high sensitivity and a high frame rate. This is what I use for capturing ISS. Because it is so small, to get some better details, I think I need a bigger scope. I am using a 14-inch tracking Dobsonian that I got once when it was on a big sale. And it's hooked up with a camera with a 3x bottle. So the field of view is extremely small. Because of the speed of ISS is moving across the sky is not uniform, I decided to track ISS by hand. By the way, I've seen images produced by 8-inch telescope. These are great images, but of course, the bigger the scope, the better in theory it will be. But I think 8 inches is the minimum for taking some close-up shot for ISS. Here you can see a video in normal speed, how fast ISS is actually moving across the sky. So on top of the tree, you see the bright dot. That was ISS in 2022. So it was moving pretty fast in the sky. This is like in regular speed. So I was holding my Dobsonian, trying to track it as good as possible. And that's how we shoot ISS. Now, tracking manually wasn't easy to begin with. But just like astrophotography in many areas, we learn from mistakes. One incident that I was checking the heavens above website, knowing that ISS will fly over at around 3 a.m. So I got everything set up and ready. So at 3 a.m., I got out in the backyard. My heart was pounding and ready to take my shot. However, I was like, where is it? It is supposed to be there at any moment. I thought the ISS changed the orbit, so I double-checked the data. No, it's supposed to be there. So, and guess what? After a few minutes, I packed up and got back inside the house at around 3:30. I was a little bit upset and disappointed, but after looking at websites clearly, like what I've shown you here, I can see that, ISS were only illuminated near the horizon during that time. So for most part of the path of the ISS, it was in the Earth's shadow. I learned my lesson. And after that time, I had to look at the information very accurately. Now, alignment between the main scope and the finder scope is also very important because the field of view is extremely small. Originally, I used the finder scope that goes with the Dobsonian. Man, it drove me crazy because everything I see was left and right, top and bottom flipped. So later on, I replaced the finder scope with the Explorer Scientific Reflex Sight. It is just like a tarot, but it helped so much. Here's a setting of my setup for your reference. If you want to give it a try, remember to test out a specific setting that works for your setup. For the first time, if it doesn't work, we need to eliminate if the problem was related to bad seeing. So once you have very good seeing, this is a real test for the setting of your system. For the first attempt, it was interesting because my hand tracking skill was pretty bad. ISS were found only in 1% of the 18,000 frames that I captured, and only 7 frames were useful. And for the first timer, I had no clue what I was doing. I actually physically eyeball each frame one by one for 4 hours to identify useful frames. It was painful. As I said earlier, for every problem, there's always a solution. Now I know there's a free software, PIPP, that can automatically screen out, center, and crop the frame with ISS for me, all done by the software automatically. And here's the interface for PIPP. It is a free software. And this is the result of my first attempt in 2022. My second attempt was a little bit better. ISS appeared in 15% of the overall captured frame. And here are the results for my second attempt ever for ISS photography. Now, for those who wonder, this is the raw video of what produced by PIPP. So you see ISS is centered in the frame. For you, only those frames with ISS in it will be captured and cropped. You can see as it goes beyond the meridian line, it will change the orientation immediately. So I can say ISS imaging is also an example for lucky imaging. It is very depending on the atmospheric condition. All I need is just a few adjacent frames with good clarity. Again, it depends on the atmospheric condition, depends on the seeing so much. At that second when the frames are taken, especially when it is going above your head. If I'm lucky, and if I get good frames, I will proceed to processing the pictures. I will stack the frames using auto-staggered, sharpening using IMPPG, or touch-up using Photoshop or GIMP. This is the result of my ISS picture in 2022. You can see I get identified many of the features of the space station. And at the end of 2022, after 5 attempts, I was lucky to get a very good seeing that night, and I got a pretty decent picture for the ISS. This is my 7th attempt in 2023, last year. In my 12th attempt in 2023, you can see is to me, there's a good improvement in my images. My mono camera is sensitive and it has good frame rate and pixel size. Then I thought, well, can I make it in color? This got into huge debate on internet, on social media. So the debating topic after I posted the picture was that, is that an authentic picture or not? If I colorize my picture using AI, I use the website to colorize it using artificial intelligence AI, is it authentic or not? It generated a lot of discussion on internet. My standpoint to this is that I always disclose the fact that the colors it artificially added. The color is not the actual color of the ISS, but I obtained all other non-color data from my shots. And I thought, wait a second, this is my hobby. I'm not trying to produce any scientific research grade level picture for scientific use. So personally, I think colorizing it this way is acceptable to me. But of course, some people don't agree with that. This is my 3rd attempt in this year, 2024, April 26. And this is my last attempt, my 6th attempt this year in 2024. And I'm pretty happy with the result. You can see a lot of details on the space station. Now, can we track ISS mechanically? Yes and no. We can certainly track ISS using specific software. For example, this software works with Skywatcher mount to track satellites especially. This one is called PrevisSat. It tracks satellites as well. This is my personal recommendation. It's called the SkyTrack. They're all free software. Because this one works with me visually. I was able to see the satellite, whether it's ISS or other satellites, in the eyepiece visually there was no problem. However, tracking satellite by software is tricky. It works fine visually. However, with the small field of view, and when the target is so small, if we want to track it accurately, I found that we need high-end tracking mount. I simply just can't afford one of them. So, and for equatorial mount, it will take a while for the mount to flip after the meridian line. By the time the mount is flipped, I bet the ISS is already gone. So considering all these factors, I decided to track it manually. That will give me a better chance of success. Because my Dobsonian, the tracking mount is not really that good in terms of tracking capacity. So lastly, I want to say that, I'm happy with the ISS picture that I took, but there are amazing pictures out there. This astrophysics is located in the Middle East, and he tracked ISS using high-end mount and software. You can see this is amazing. Look at all these details Michael can produce. So again, thank you for letting me to share my pictures with you, and I'm more than happy to connect with all of you through my social media account. I would like to, and I'm looking forward to opportunities to learn and grow with each other through my social media accounts here. And thank you so much for having me this evening.
Benjamin, wow, you do amazing imaging. Amazing.
Thank you.
Those solar flares and prominences and the ISS images, really, really good work. Thank you so much for showing and sharing with us. And also thanks for putting together such a great presentation in a short amount of time, because it was only a week ago that I reached out to you and asked if you could present, and you said yes, and within a week you pulled together a very good presentation. Thank you for your hard work.
You're very welcome. Thank you.
Enyo, do we have any questions for Benjamin?
Yes, we do. Pardon me. We have several comments complimenting you on your images and on your experimenting. Very well done, and I'd like to add my own compliment to that. Two questions, both from Louis R. And I'll say them both together if I may. How much time do you take to prep for the photos? And his other question is, so are you taking photos of the ISS tomorrow morning? Supposed to be viewable from Toronto.
So first question, how much time do I prepare for it? Well, it depends. It depends. First of all, I constantly have different apps checking the weather forecast. And I usually, if I'm ready to take some pictures, I look at the forecast ahead of time and make sure that I can prepare for setting up everything ahead of time. But for solar imaging, it could be very spontaneous. So for example, I shown you the solar prominences this morning. I had a website here. I can just check the real-time appearance of the solar disk. And I thought, wow, there's a big solar prominences. And I have some time today, so I just set it up and take the shot. But for ISS, yes, I need to prepare a little bit more. For tomorrow morning, I'm not sure about the forecast for tomorrow morning yet, but it depends on the altitude of the ISS, depends on like the position, because I'm living in the city, so I'm surrounded by lots of houses and around my backyard. So I have to look at whether the ISS would be perfectly visible in my backyard, and also I have to check the seeing condition of the sky at that time. So if the prediction from my app saying that the seeing is not quite good, I would choose sleeping over that, because I just can't spend every single night when it is above the sky and stay up late that night. Because for ISS photography, it is pretty tricky that you can always see that illuminated a few hours after sunset and maybe a couple of hours before sunrise. And any other time, ISS will be inside the Earth's shadow, and you won't be able to see that illuminated. So it is either shortly after sunset or in the middle of the night before sunrise. So I have to make sure that everything is good and promising before I can actually just bring my telescope out.
Very cool. Another question just came in from Darren. What was your biggest factor in your improvement? Camera settings or processing or atmospheric stability? And thanks for a great presentation.
Thank you. I would say atmospheric stability is only lucky. That's why I said it is a lucky imaging process. So, but when you have lucky imaging, I would say I try a lot. So let's say for ISS last year, 2023, I try at least 15 times. Whenever it's available, when the sky is kind of clear, I kind of practice the tracking, practice processing. There are many failures picture I did not show you there, but I think just this is why I like this hobby. It is difficult, it is challenging, but I know one thing for sure: if any one of us would like to try this, astrophotography, whatever in any domain, just keep trying, because I know that the more we attempt, the better we will do. Um, and I'm pretty sure about it. So by accumulating failure experience in your processing, in your data taking process, we can always improve in this hobby.
Thank you, and that's all of our questions.
Great.
Thank you, and thanks again, Benjamin.
Thank you.
All right, so that concludes our presentations for this evening. I'll call on our president, Tom Luton, to take care of announcements.
All right, and thank you very much, Paul, and thank you very much to our presenters this evening. All right, let's get some announcements going then. So, as Paul has mentioned, and as you've probably heard, the Science Center was officially closed immediately, effective as of June 21st. What this means for us is all recreational astronomy nights are online only. All solar observing at the Ontario Science Center is canceled, and all star parties at the Ontario Science Center are canceled. Please take a moment to think about our friends at the Science Center who, while at the moment we are facing an inconvenience, they are facing the loss of their jobs. What does this mean for RASC Toronto Centre going forward? At the moment, we're currently in talks with York University and the U of T for new meeting space and outreach possibilities. We'll give you the full details when an agreement is made, but at the moment, recreational astronomy nights are tentatively expected to return to in-person meetings in September. Now, I'd like to repeat Paul's welcome to everyone who's joining us live. We've got two types of meetings. You've just seen one of our recreational astronomy nights, and then in September, our speakers nights will be restarting for the fall season. For those of you who are joining us live, hello. Please say hello in the chat. Please enter some questions for the presenters. If you're a new member, please introduce yourself. And if you're coming to us from far outside the Toronto area, please let us know where you're coming from. I am coming to you from my couch in my apartment in Toronto. So our next recreational astronomy night is online only, as I just said. The 7th of August, 7:30 p.m. Please join us here on YouTube. Arnold Brody will be talking about the sky this month. Pavle Krasnopolski will be doing a second presentation, this time Beware the Red Light. And as Paul mentioned earlier, we've got room for one more presentation. Please drop Paul a line if you've got something you'd like to present. And like I said earlier, we're currently on our summer break for our speakers nights, so we'll be restarting that in September. Now, I'd like to invite all the Toronto Centre members to the open house and awards picnic this Saturday, July 6th at the Carr Astronomical Observatory near Thornbury. The award ceremony, there'll be rocket launches and a potluck barbecue dinner. The CAO is free to use for the weekend. You have to book a space via the CAO booking page on the website, even if you are not staying overnight. We want to get a handle on how many people are going to actually show up. Coming up, what we are getting involved with in the Toronto area in the next month, City Star Party for Rask Toronto Centre members only, Bayview Village Park, the first clear night of the week of June 8th to 11th. So that's Monday, Tuesday, or Thursday, 8 p.m. to 11 p.m. Millennium Square Public Stargazing on Friday, July 12th, 7 to midnight. Join us for an evening of free public stargazing on the North Shore of Lake Ontario, Millennium Square in Pickering. Observe the moon, stars through our telescopes, check out our astronomy literature at the booth, ask us some questions. If you've got your own little telescope you'd like to get some advice and help on, please bring it along. We'll be happy to set it up, help you set it up, and aim it at the moon. Remember that it's cooler down by the lake, and please check our website for a go, no-go decision based on the weather before heading to the square. Coming up at the David Dunham Observatory in the next few weeks. The first clear night of the week of July 15th to 18th, starting at sunset, is DDO Stargazing Night. Bring your own binoculars. No registration is required. Just walk on in. Then on Friday, July 19th, from 10 p.m. to midnight, is DDO Astronomy Family Night. Registration fee is as shown here. You can register online. The links to the Richmond Hill website can be found at raskto.ca. There's a second DDO Astronomy Family Night on Saturday, July 27th, also 10 p.m. to midnight. And then on Sunday, July 28th, from 12:30 to 1:30 p.m. is Sunday Sungazing. Again, registration fees are as here, and the links can be found at raskto.ca. The Carr Astronomical Observatory operations of the CAO are largely back to pre-pandemic conditions. Masking in common areas is still encouraged, but the people who are actually in attendance, the preference will be taken. Please see the online CAO bookings page for all details at toronto.rask.ca/content/CAO bookings. Just a reminder that even with our Science Center activities now canceled, the Toronto Center still needs volunteer help. So if you're a Rask Toronto Center member and are interested in helping out, and if you've got some free time, please contact the volunteer coordination team, volunteer@raskto.ca. Rask Toronto Center is now working with Benevity to receive charitable donations. If you're a volunteer and your employer has signed up to make contributions for charitable work, please let us know, either myself at president@raskto.ca or our treasurer at treasurer@raskto.ca. This is the part where I get to plug the joys of Rask membership. If you have been watching us and if you like what we've been doing and want to be a part of the Rask family, you can sign up or renew online at secure.rask.ca. Gift memberships are also available. Contact the national office at mempub@rask.ca for more details. And with that, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. Please follow us on all the forms of social media we've got listed here. If you like what you've seen here on YouTube, please like, subscribe, hit the notification bell. Stay safe and keep looking up. Good night, everyone.